Hello. I'll be starting with a brief slide deck, and then I'll be going through a data flow diagram, and then finally I'll be giving a live demonstration of the application. So, the question of the day is, what do you do when your bank has problems such as fragmented customer data, no real-time updates, outdated on-premises infrastructure? Well, you do VaultGuard, your new secure banking web app. See, all of these problems can be solved by a cloud-native web application like VaultGuard. For example, fragmented customer data, store it all in cloud databases, and ensure that the databases can communicate with each other. No real-time updates? All real-time updates, with all transactions, API, endpoint activity, everything logged and viewable within seconds in CloudWatch, and double logged to an encrypted S3 bucket with delete protection. Outdated on-premises infrastructure? Don't have any on-prem infrastructure. You can use cloud-native infrastructure, and you can scale your resources as needed, and you can pay as you go. But does VaultGuard satisfy actual regulations? Yes, it does. So some regulations have a lot in common, such as most regulations requiring encryption, access control, authentication, and audit logging. For encryption, all data at rest in VaultGuard is encrypted using Amazon server-side encryption with a customer-managed key for enhanced logging. And in transit, the data is encrypted using TLS. Access control, all IAM policies are scoped to least privilege principles, and many of them are scoped to individual resources to prevent scope creep. Authentication, so two-factor Cognito authentication is used to log into the service and get a Java Web Token, and then a Cognito authorizer is used to actually access any of the services in the app. And all logs are recorded twice, once to CloudWatch, once to a write once read mini S3 bucket with encryption and delete protection for auditing purposes. So if the payment card industry data security is standard, network segmentation, well, VaultGuard runs entirely on its own private VPC on the Amazon Web Services. Payment security, there's logic in the Lambda functions to reject improper transactions. And cardholder data protection, no card data is transmitted directly, and anything involving banking information is returned via pre-signed URL, such as bank statements. What about SOX guidelines? Well, VaultGuard is audit ready. All log information is stored in a undeletable S3 bucket with governance policies and object protection enabled. For change management purposes, all changes to VaultGuard are recorded on the public GitHub repository and viewable and auditable by anyone. And reliable recording, VaultGuard has scaling capacities and failover protection, meaning it is a high availability web app. So it's always available for auditing and reporting. And for consumer protections, the GLBA, VaultGuard collects no user data except for whatever users want to customize in their profile, and none of that user information is ever shared with any third parties except for the necessary AWS who is hosting the infrastructure. And all the employees of VaultGuard are fully trained and ready for operation. Let's upgrade to VaultGuard today. And let's go over a data flow diagram. So, the user either can log in via Cognito, or they can access the home page directly, in which case they are forced to redirect to a Cognito login. Once they log in successfully and complete the multi-factor authentication challenge, they're given a Java Web Token that's valid for 60 minutes, no longer. It's revocable, and it is necessary for all authentication. So they get their token, they're redirected back to the home page. From the home page, they can click on their profile, get their profile, they can make transactions, all that stuff. And anytime the user wants to do something, the app uses a REST API, so they're issuing HTTP requests and including their Java Web Token. Those requests hit the API gateway, and the API gateway has a Cognito authorizer enabled. So the authorizer will check their web token, and if the token is valid, it will pass the request on to the Lambda. Additionally, the Cognito authorizer will decode the information in the web token and pass that information into the event for the Lambda handler in the Lambda function. So anything performed by the Lambdas involving user information, like get from this bank statement or transfer from this account, all of that information is coming directly from the Cognito authorizer, pulling that from the token. And there are 5 different Lambdas for functionality and 1 for logging. The functionality ones, they can do stuff like pull information from a DynamoDB, like profile information, or update that profile information, push it to the DynamoDB. They can get your transaction history from an Aurora database, which is serverless and automatically scaling, and includes multiple read and write instances for failover protection. So that's the Aurora is giving us reliability and scalability there. You can also update your balance, of course. Or you can view your statement, your bank statement. In that case, the Lambda will request it from an encrypted S3 bucket, which will return a pre-signed URL to you, and all this other data is also returned to you after authentication. So let's see it in action. Let's get the web endpoint. So here we are. Alright, automatically redirected to the login page. Let's log in using our test user with a very secure password. And let's do the MFA challenge. 605 575. Alright, we successfully signed in. We redirected back to the main page, and it is identifying us correctly as the user that we signed in as. Very important. Let's check our profile. Alright, that's us, John Smith. We cannot edit this field without talking to the bank first. We can't edit our email either. But we can change our preferred language. I want to change it to Spanish, and I want paperless communication. No more paper bills. That preference is updated successfully. Very good. If we navigate away and then navigate back, it keeps our preferences. So change it to English. And let's view our statement real quick. So in this page, it returns a pre-signed URL so that we can see our statement. Looking good. Everything looks normal. What we expect. And let's look at our transactions history. So this is our transaction history. Recent transactions. Let's make a transfer. I want to deposit $150 for video made me money. Alright, transaction recorded, balance updated, shows us our current balance and gives us a confirmation number. Our transactions, there it is right there, video made money, you can see it right there. And let's try to withdraw, let's withdraw $150,000 because I want money. I want money. Let's see. Oh, transfer canceled, couldn't do it, insufficient funds. And let's look at our log. Didn't make it into the log because it never happened. So it blocks improper transactions as well. So let's go back and log out. It does that sometimes. There we go. And there we go. Redirected back to the sign-in page. Perfect. Let's check out our Aurora database real quick. So these databases are great because they're serverless. They can go down to 0 compute capacity to save money. But when they're needed, they can scale as much as they need to. And you can even add additional reader and writer instances. You can automate this, or you can do it manually. Both of them provide substantial failover protection and redundancy. Very useful. And all of this, hosting this entire app, the research and development for it, it all only costs about $5. And basically, a little bit of that is the key management service. Absolutely worth its money. But most of that money is from Aurora, because Aurora isn't cheap, but it is reliable. So, still pretty good though, pretty low money. So, this has been the entire app, and all of the code for the Lambda functions themselves can be seen on my public GitHub, the AWS Lambda functions, as well as all the necessary code for VaultGuard itself. And real quick, let's just check that S3 bucket. So we've got a bunch of buckets here. Here is our forwarded logs bucket. So this bucket has is delete protected. It has object lock enabled, has governance policies in place, and the logs transferred into this bucket cannot be deleted without root access, and that makes it completely auditable for all of our functions. And the app itself is stored right here, run completely out of an S3 bucket using CloudFormation or using CloudFront. And here's the website itself. This is here's the website itself. Everything is run from this bucket directly. All right. Thank you very much for watching.